And hi everyone. Alright, let's go through this test. Alright, numbers 1 and 2, we have to simplify the expression. Let's remember sine squared x plus cosine squared x is equal to 1. So sine squared x is equal to 1 minus cosine squared x. Now when I look at this is the exact opposite sign of these two. This one's positive, that one's negative, this one's negative, that's positive. So I'm just going to make negative sine squared x equal to negative 1 plus cosine squared x, which is what that is. So this is equal to 1 over sine squared x. And then the reciprocal of sine is cosecant. So that's how I'm going to simplify 1 over cosine squared x minus 1. Now, this second one. One over cosine theta plus 1. I'm going to try to make this into one fraction. So I'm going to multiply this one by cosine theta minus 1 over cosine theta minus 1 minus 1 over cosine theta minus 1 times cosine theta plus 1 over cosine theta plus 1. And when I go through and multiply this, this is cosine theta minus 1 minus cosine theta plus 1 over my common denominator. This looks like difference of squares. Cosine squared theta minus 1. Alright. Cosine minus cosine cancels. Negative 1 minus 1, that's negative 2 over cosine squared theta minus 1. It seems like I've dealt with that already before. Alright, negative 2 over negative sine squared theta. And the negatives cancel out. So that's 2 over sine squared theta. And that's 2 times 1 over sine squared theta. The reason I'm doing that is because I want to use the cosecant again. 2 cosecant squared theta. Alright, now it's just kind of coincidental those two are that much alike. Okay. Now this next one. I'm going to work with this side. And what I'm going to do, and I'm try to make it look like this side, I'm going to take cosine alpha over 1 minus sine alpha. I'm going to do something like the conjugate, use that. Multiply this by 1 plus sine alpha. And that gives me cosine alpha times 1 plus sine alpha over 1 minus sine squared alpha. Erase this. And sine squared alpha here. I have to write square. And that looks like cosine alpha times 1 plus sine alpha over cosine squared alpha. And this one cosine will cancel out with one of those cosines. So let me just continue working in this direction. I got 1 plus sine alpha over cosine alpha. Now, I did see someone working this problem. they had distributed, which there's nothing wrong with distributing, but then they had to go back and factor again, back to this original form here, to get this canceling done that we just did right here. And I can split up this numerator into two fractions here. 1 over cosine alpha plus sine alpha over cosine alpha. And 1 over cosine alpha is secant alpha, and sine over cosine is tangent alpha. So secant alpha plus tangent alpha leads us to what we were looking for. Alright, let's see if we can get this one to work. And I think I'll work with this side. It is we usually work with the more challenging side. And the thing I'm seeing here is I think maybe this has the common factor of cotangent. So I'm going to take secant cotangent x. So I'm going to take secant squared x minus 1, and that equals tangent x. Let's see. And we want secant, so that's secant is 1 over cosine. So this is tangent squared x plus 1 equals secant squared x. And if I subtract 1, this is cotangent x times tangent squared x. Alright, I had to derive that because I forgot. And I'm going to split it up this way. I'm going to go cotangent x times, well, I'm going to actually just call this 1 over tangent x. Times tangent squared x. One of these, that tangent cancels with one of those, and we're left with tangent of x, which leads us back to here. Okay. Now, next part here. Okay, cosine of x equals 1 minus cosine of x. And I'm going to solve for x, but the first thing I want to do is get the trig functions all together. 1 and 1, that's 2 cosine x equals 1. I'll divide by 2. And cosine of x is equal to 1/2. Alright, where is the cosine of x equal to 1/2? Cosine's 1/2. So like right here and right here, this is pi over 3. And this is 3 pi over 2. Just 9 pi over, this is 5 pi over 3, I think. So x is equal to pi over 3 plus 2 pi n, or 5 pi over 3 plus 2 pi n to get all the coterminal angles there. Alright, now number 6. I'm going to subtract square root of 3 from both sides. I got 2 sine of 3x equals negative square root of 3. Divide by 2. I got the sine of 3x equals negative square root of 3 over 2. Alright, where's sine negative? That would be here and over here. So I think 5 pi over 3 is one of them. And this is 4 pi over 3, I believe. Yeah. Those look like the two places where the sign is at negative radical 3 over 2. So three x is equal to 4 pi over 3 plus 2 pi n, or 3x equals 5 pi over 3 plus 2 pi n. Divide through by 3 here, and you've got x is, this is just timesing by a third, is 4 pi over 9 plus 2 pi n over 3, or x equals, divide by 3, 5 pi over 9 plus 2 pi n over 3. Alright, now number 7. Find all of the solutions of tangent squared x. So let's do that. We got tangent squared x minus 3 tangent x plus 2 equals 0. I'm doing that because I think I'm going to factor. And you know what multiplies to 2 and adds to negative 3? Looks to me like that's tangent x minus 2 times tangent x minus 1 equals 0. So tangent x minus 2 equals 0, or tangent x minus 1 equals 0. So tangent of x equals 2, or tangent of x equals 1. Now, this is in the interval 0 to 2 pi. Okay. This is at pi over 4. That's when we have the radical 2 over 2 and radical 2 over 2. And we also have it here at 5 pi over 4. And we'd have something like right here and down here. So I'm going to write the exact values, and I'm probably adding a little more to this than I would, but for tangent of x equals 1, x is equal to pi over 4 and 5 pi over 4. For tangent of x equals 2, and we're going exact here, so I'm just going to write the inverse tangent of 2. And that would be somewhere right over here. It's like when the sine value is twice as big as the cosine value. And I'm going to add one here, because right here, which is pi units away, I'm going to write the inverse tangent of 2, and I'm going to add pi to it. And that's just the exact form. Okay, now you may have gotten this one. This is the first time I've shown you this. If you're able to come up with that, good for you. If you don't, I don't think I would penalize you, but I think I would reward that with a little extra on that one. Okay, number 8. Find the exact values. Okie dokie. Alright. Cosine of negative 15. The cosine of 30 minus 45. That makes negative 15. And cosine of the difference. That's cosine U, cosine V. So cosine 30 degrees, cosine 45 degrees. I'm going to run into the next problem, so I'm going to write that right here. The minus, we use a plus there. Plus sine 30 degrees, sine of 45 degrees. Alrighty. Cosine of 30. Right there. Cosine of 30. That's the square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Plus the sine of 30. That is... sine of 30 is 1/2. Sine of 45 is square root of 2 over 2. So radical 6 over 4 plus radical 2 over 4, which is radical 6 plus radical 2 over 4. All right. Tangent of 17 pi over 12. Okay, I know 8 and 9 make 17, and that will cancel some with the 12, so I'm having a feeling that that'll make some difference on the unit circle. So I'm going to tangent of 8 pi over 12 plus 9 pi over 12, which is the tangent of 8 divided by 4, 2 pi over 3, plus 3 pi over 4. Okay, need to look at those real quick. Let's see, 2 pi over 3. This is, that'd be right here. And that is let's see, negative 1/2 and square root of 3 over 2. And 3 pi over 4 is right there. And that's negative square root of 2 over 2 and positive square root of 2 over 2. The tangent is the sine over the cosine, and sine over cosine. So this one is, the tangent is the negative square root of 3. This one, the tangent is negative 1. Okay, just to get it set up, just so I have those values that I need. So, for tangent and sum, I'll take the tangent, this is u, this is v, tangent of 2 pi over 3 plus tangent of 3 pi over 4 over 1 minus tangent 2 pi over 3 times tangent 3 pi over 4. Alright, tangent of 2 pi over 3. That's this one. That's the negative square root of 3. Tangent of 3 pi over 4 is negative 1. This is 1 minus negative square root of 3. It's not a fraction. Times negative 1. So I am looking at negative square root of 3 minus 1 over 1, and this is a positive when you multiply the negative and the negative. 1 minus square root of 3. Or 1 minus square root of 3. Let me rewrite that. let's go -1 minus square root of 3. Let's go 1 minus square root of 3. And I'm going to multiply by the conjugate there. That's 1 plus square root of 3 here. And 1 plus square root of 3 here. Okay, I got -1. Outside I got negative radical 3. Inside I get negative radical 3. And last, I get -3 over 1 minus 3. That's a difference of squares. The middle parts cancel out. So that is -1 minus, nope, I'm going to go -4 minus 2 radical 3 over -2. -4 over -2, that's 2. -2 over -2 is +1. You have 2 plus radical 3 for the tangent there. And then this last one, sine of 120 plus 45, that is the, right, is a sine, cosine, or tangent. Sine, cosine, plus cosine, sine. That looks like the sine of 120 degrees plus 45 degrees, which is the sine of 165 degrees. And I suppose if I were given the exact value, I'd have to use this again. So this is one part of it. The second part, the sine of 120, let me kind of think where 120 is real quick. There's 90, so 120 is right there. The sine is the square root of 3 over 2 times cosine of 45 is square root of 2 over 2. Cosine of 120 is -1/2. And sine of 45 is square root of 2 over 2. So we're looking at the square root of 6 over 4 minus square root of 2 over 4. So the exact value is square root of 6 minus square root of 2 over 4. And that's what the sine of 165 is equal to. All right. You guys have a good test on this, okay?